Hi guys, welcome to Superchem video lessons. This video lesson is on organic chemistry. We are looking at how to name hydrocarbons, and then we are looking specifically at branched chain alkanes. And this is part 2 because we've already started naming branching alkanes in lesson 3. So in lesson 3, our previous lesson, we looked at branching alkanes that have only one substituent, like this example, something like this. We got to know that a branching alkane has a parent chain, that would be the longest chain, and then it has a substituent. Okay, so we got to know that something like this can be named as this, where the parent chain will have a name, a parent name, and then it is preceded by a prefix which talks about the substituent. Right, so we are going to look at more complex examples of branching alkanes that have 2 or more substituents. Right, like what we have right here. This is an example of a branching alkane that has 2 substituents, methyl and ethyl. Okay, let's get started right now. So we are looking at our first example. There you have it. So the first thing you have to do is to know your longest chain. So let's begin counting from the far left here. 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 carbon atoms. Is that the longest chain? You can check by counting from other ends of the compound to see if you have a longer chain than the 7. 1, 2, 3, 4, 5, 6. So obviously the longest chain is this, 7. You can also count from here 1, 2, 3, 4, 5, 6, 7. So you can choose any of the 2 in this case. So we go for the straight one. So when you get your longest chain, what you have to do is to mark it out. Alright, like this. So you mark it out, and then what do you get? You'll be left with 2 substituents here. So in naming, you have to first name your parent chain. Here it has 7 carbon atoms, so our parent chain is heptane. Alright, so now let's move on to our substituents. The substituents are 2. The first one is methyl, the other is ethyl. How do you arrange your substituents? We do so in alphabetical order. Ethyl starts with E, whilst methyl starts with M. So what we do is that we bring ethyl before methyl. And then something that is very important is their locations. So for each of your substituents, you have to show their locations. So you count your parent chain. So here we are counting from our far left here, 1, 2, 3, 4, 5, 6, 7. So when we give these carbon atom numbers, our methyl is found on the second, this one, and then our ethyl is found on the third, on the 4th carbon in the parent chain, so 4. So write the number, you bring a hyphen followed by the name of the substituent, then you bring a hyphen again before the location, the location number of the second substituent, then a hyphen again, then write the name of the substituent. When you are done with the substituent, you follow it up with the name of the parent chain, which is heptane here. So that is what you do. Our compound's name is 4-ethyl 2-methyl heptane. Alright, so let's carry on to example 2. In example 2, we once again look at our longest chain. So let's count 1, 2, 3, 4, 5. So our longest chain here is 5. So we mark it out, and then we realize that we have two substituents, this and that. Alright, so one thing you have to note about our substituents is that they are the same. In this case, they are both methyl substituents. So are you going to write methyl and then write again another methyl? No, we are going to put them together because they are the same. So we bring something in front of them, di. So di will come in front of the word methyl to indicate, to tell us that we have two methyl we are dealing with, or as substituents. So dimethyl. And then you have to show the location numbers for each of the methyl. So the first one, when you count from here, 1, 2, has a location of 2. It's on the second carbon atom in the parent chain. And the next one is on the third carbon in the parent chain. So we have 2, then we bring comma 3, then we bring a hyphen. Then because they are 2, dimethyl. Then you follow it up with the parent name, which is pentane. So easy, that is what we do. 2,3-dimethyl pentane is the name for this compound. Okay, so let's check out our third example. In this third example, once again, we have to fish out for our longest chain. So 1, 2, 3, 4, 5. That is 1. We can also count 1, 2, 3, 4, 5, 6. So obviously that's going to be our longest chain. Alright, so we mark our longest chain out. We have 6 carbon atoms in our longest chain, so it's hexane. We have 2 substituents, methyl and methyl. So we bring our parent name, which is hexane, 2 methyl substituents, so we write dimethyl. Then we show their locations. When you count from the left here, we have 1, 2, 3, 4. So the position for the first methyl is 2, the second one is 4. They are separated by a comma. Then we bring a hyphen, dimethyl hexane. Someone can also go for the option where you count from the back here, 1, 2, 3, 4, 5, 6. But when you count from that direction, the number for this methyl, the location number is going to be 3, and then 4, 5. The next one is going to be 5. So 3 and 5 are larger numbers than 2 and 4. So we go for a smaller number, 2 and 4, a smaller set of numbers for our substituents, 2 and 4. Always make sure that your substituents have the lowest numbers possible. Alright, so 2,4-dimethyl hexane is the name for this compound. So our next example, we have it here. What is going to be our longest chain? 1, 2, 3, 4, 5, 6. Is that going to be the longest chain? Okay, let's count again in another direction. 1, 2, 3, 4, 5, 6, 7. Alright, so we are going for 7. That is going to be our longest chain. So you mark it out. So marking it out, we have 2 substituents. So in writing the name, we are going to first write the parent name, heptane. Then we have 2 substituents, ethyl and methyl. Ethyl comes before methyl, so ethyl, methyl. Then we count and then give them their locations. So we start counting from here, 1, 2, 3, 4, 5, 6, 7. So methyl is going to be 2 here, then ethyl is going to be 4. So 4 ethyl, 2 methyl heptane is the name for our compound. Alright, so we have our fifth example. This fifth example, let's check out the longest chain. We have 1, 2, 3, 4. So 1, 2, 3, 4. It's going to be the longest chain. We mark it out. Okay. We single it out and we'll be left with 2 methyl substituents. So 1 and 2. So our name is going to be, the parent name is butane from the parent chain, butane, and then we have 2 substituents. They are both methyl, so dimethyl. And then they are both found on the same carbon, so their locations are the same. So the first one is 2, then the other one too is 2. So we have 2,2-dimethyl butane. All right, so moving on to the 6th example. So this is our 6th example. We fish out for the longest chain. So 1, 2, 3, 4, 5. Okay, is that the longest chain? We can also try 1, 2, 3, 4, and 5. So when you go this way, you can even go this way: 1, 2, 3, 4, 5. When you go straight, we are going to have ethyl and methyl as our substituents. When you go the other direction, 1, 2, 3, 4, 5, you are still going to have ethyl and methyl as our substituents. If you go 1, 2, 3, 4, 5, you are going to have this ethyl and methyl as our substituent. So we can choose any of them. Our results is going to be the same. So we are going for the straight one. We mark it out. We have 1, 2, 3, 4, 5. Okay, so pentane. So our substituents are methyl and ethyl. In naming, we bring our parent name, pentane, and then ethyl comes before methyl. So ethyl and the methyl are substituents. They are all both found on the 3rd carbon. So 3 and 3 for each of them. So 3 ethyl, 3 methyl, pentane. Okay, so we are good to go to the next example, 7th example. There you have it. So you have to name it. Okay, so fetching out for the longest chain, and the longest chain is going to be 1, 2, 3, 4, 5, 6, 7. So when you choose this, our substituents is going to be here, this one and that one. Okay, so we have 2 substituents. If you start counting from here, 1, 2, 3, 4, 5, 6, 7. Okay, is there another way to count to see if you have a longer chain? Let's count from 1, 2, 3, 4, 5. You know, go up, let's go straight. 6, 7. When you go that way, we are having 1, 2, and 3 as our substituent. So which one do we go for? We have 2 long chains, they are both 7. So we go for the one that gives us more substituents. So we go for this 1, 2, 3, 4, 5, 6, 7. This provides us with 3 substituents, one more than the other option. So we go for this. So in naming, we name our parent chain as heptane because it has 7 carbon atoms. Then we have dimethyl because we have 2 methyl substituents. So dimethyl. Their locations will be, when you count from here, 1, 2, 3, 4, 5. 2 and 5. This one is 5, the other is 2. Then ethyl is 3. So 3 ethyl, 2, 5 dimethyl heptane. So here quickly I want to mention something here. It's very, very important. It keeps on confusing a lot of people. So here you realize that ethyl starts with E, but we have dimethyl. So in ordering your substituents, if you don't know, you would bring the dimethyl before ethyl because of the D. But the D is insignificant when you are ordering your substituents. You look at the M, you don't look at the D. So ethyl still comes before methyl. Regardless of the D in front of it, you go for ethyl first and then methyl. The D is just a prefix for your 2 substituents. Okay, so it's going to be 3 ethyl, 2, 5 dimethyl heptane. Okay, so looking at our 8th example, so which is going to be our longest chain. So let's go this way. 1, 2, 3, 4, 5, 6, 7, 8. So our longest chain is going to be 8. That is octane. 1, 2, 3, 4, 5, 6, 7, 8. And it provides us with, it will be left with 3 substituents. So we have the substituent propyl here. Yes, let's check our table of alkyl groups substituent. So you see that when you have CH2, CH2, CH3, then you have a propyl substituent. Okay, so in naming, you bring your parent name first. For your parent chain, octane, that is octane, you bring it first. So E comes before M, M comes before P. So you have ethyl, methyl, propyl. Then you move on to their locations. So where are you going to count from? So let's count from here. 1, 2, 3, 4, 5, 6, 7, 8. When you count from in that direction, our ethyl and propyl are going to have 5, and then methyl is going to have 5, 6, 7 as its location. So it's not going to help us. Let's count from the left to the right. 1, 2, 3, 4. So you realize that when you count in this direction, we have smaller numbers for the locations of our substituents. So we go for that direction. So ethyl is 4, propyl is also on the 4th, and then methyl is on the 2nd. So there you have it. The name is 4-ethyl, 2-methyl, 4-propyl, octane. All right. Okay, so we continuing, and then we have our 9th example. Okay, so our 9th example, let's count and then find out our longest chain. 1, 2, 3, 4, 5, 6, 7. That is 1. You can also count it in this way. 1, 2, 3, 4, 5, 6, 7. So we have this, and then the first one when you go straight through. So which one do we choose? Okay, so let's go with the first option. So we are choosing 1, 2, 3, 4, 5. Instead of going straight, we go down 6, 7. So when you choose this, how many substituents are we having? We're having 1, 2, and this whole thing is a substituent, CH bonded to CH3 and C3. That is isopropyl. So from our table, I think we have it here. So isopropyl, that is it. That's the substituent. Okay, so we have it here. Okay, so 3 substituents. So when you go with this, the name is going to be, when you count from here, 1, 2, 3, 4, 5. 3 isopropyl, 5, 5-dimethyl heptane. But is this right? No, it's wrong. Okay, why is it wrong? We will know in a bit. I've already explained in the other examples, but let's look at it very critically here. So when we look at choose the other option, 1, 2, 3, 4, 5, instead of going down, we go straight 6, 7. When you choose this as our long chain, our parent chain, we have 1, 2, 3, 4 substituents, one more than the other option. So we are going for this because it provides us with more substituents. So when you have the same long chains, you choose the one that gives you more substituents. So we go for this, and the name is going to be 3-ethyl. That is, we are counting from right to the left because it gives us smaller numbers for our locations. So 1, 2, 3. So ethyl is on the third carbon, 3-ethyl. Then bring our dash, then we move on to the locations for the methyls. There are 3. So counting from here, 1, 2. The first one is 2. The fifth one is on the next methyl is on the 5th carbon. Then the other one is on the 5th. So you have 5, 5. So 2, 5, 5. Tri, there are 3. So trimethylhexane. If they were 4, they would be tetra. So trimethylhexane. Okay, so that's the name for this. So this is correct. All right, so number 10, we have this compound. It is going to be very simple. So 1, 2, 3, 4, 5. So our parent chain is pentene. 1, 2, 3, 4, 5. Okay, so how many substituents are we provided with? We are provided with 1, 2, 3, 4. Okay, so we have 4 substituents. So in naming, the parent name is going to be pentene, and then because we have 4 methyl substituents, we are going to have tetramethyl, and then we show their locations. In this example, you can count from here 1, 2. So the first 2 substituents will have the names, the location numbers 1, 2, then 3, 4. So the next 2 would have the location numbers 4 and 4. Then bring a hyphen, then tetramethyl pentene. So there you have it. So this is our 10th and last example. So you can, here are some try questions you can do on your own at home. Okay, so look at them carefully. You can screenshot them. Here are more examples for you to try. 1, 2, 3. So you can try this and see if you can name them. Alright, so in our next lesson, we are going to look at how to name hydrocarbons. We are continuing that, but we are moving on to alkenes. How to name alkenes. All right, so keep calm and study hard. Bye bye.